All right, greetings. Welcome into my channel. I am Professor L, and this is a live stream for math and math tutoring. So if you have a math problem you want to see worked out, post it in the chat and I'll give it a go. In the meantime, I'm just going to be hanging out, working on my board. So I just want to welcome you in and say happy Thursday, and I hope everyone is doing well. And just go ahead and get right into it. Um, Reflecting on yesterday's graph, the graphing of the vertical oriented ellipse. So we noticed that there's a major axis and a minor axis, these two chords that intersect at the center of the ellipse. The major axis was longer than, the major axis is longer than the, what am I trying to say? The minor axis. And if it's associated with the y values, it's going to have a vertical orientation. And if it's associated with the x values or the h values, it's going to have a horizontal orientation. So what basically that equates to is this. This is the equation for an ellipse in standard form. And we, A is always bigger than B. That's how they decide whether the orientation is. And we went through that process. We're going to go ahead and go through the process one more time. However, I do want to save this equation. So what I'm going to do is I'm just going to put it in its standard form, which would be here. I'm just going to write it in here so that I can keep it real quick. X minus 2 quantity squared over 1 plus y plus 2 quantity squared over 4 equals 1. All right. And so then I think I can erase most of what's here, and this will give me a good clean workspace. And I tried to pick a horizontal oriented ellipse. And so we'll just hopefully that's what it is, and we'll give it a go. These these sessions, live stream sessions on my board, they're not rehearsed or scripted or anything. Maybe one day I'll get good and start trying to script and practice and things. This is just me hanging out and doing the math and hopefully setting a good example for what it takes to increase in your math knowledge and understanding. And it's very important. Math is, of course, everyone is thinks that their subject is the most important subject in the world. Like, I get that, but math is very important. Trying to not have a bias here. All right, so here is my new equation. Hopefully it's a horizontal and it works out, but I haven't, basically what I'm saying is I haven't graphed this thing yet. I haven't looked at it. I haven't plugged it into Desmos, nothing. So hopefully it works out. But in life, sometimes we can hope for the best, but it doesn't always work out. All right, so 16x plus 54y plus 61 equals 0. And this is the equation for an ellipse in a general form. It looks very similar to the graph or the equation for circles, hyperbolas. The parabola is a little different, but yeah, for sure, it looks like hyperbolas and circles. So there's only you know, a slight difference in the graphic in standard form, but here in this form, it's almost impossible to tell. I mean, I would think that there's a lot of people out there that are really smart and like the savants and all that, and you know, people that are really on a high level of mathematics can probably look at this and say whether it is, but it could be yeah, so it could be a circle, it could be a hyperbola, it could be ellipse. The only way that you can really find out is to rearrange it, put it in its standard form, and then that's kind of generally the method of determining which conic section you're dealing with. So we're going to go ahead and revisit that method just so we can practice completing the square 2 times. So here we go. So we're going to go ahead and group our x terms together. So we've got 4x squared and 16x. And we're going to go ahead and use a parentheses and leave some room here. Then we're going to just plus it. Plus whether that number is positive or negative out in front of y. We're going to go ahead and just plus it and then have the sign go with the number. It makes it, I think personally, it makes it a little bit easier. But in this case, it's not. It's positive already, so we don't have to worry about that. 9y squared, and that's plus 54y. And then you're going to leave some room for the parentheses. And then what we want to do is we're going to actually move this 61 to the other side by subtracting, using that property of addition for real numbers. Subtract 61 from both sides, and in the next step, we'll say that this is negative 61 here. And then here is where the fun begins. So what we're doing is we want to make sure, because anytime that you're performing a method, it's very specific. So the very first thing that you have to consider is that your leading coefficient, because this is a method for solving second-degree polynomials, you have to look at that second degree, that leading coefficient. It needs to be listed first, and you want to make sure that the coefficient is 1. So if it's not 1, then you have to make it 1 by doing some properties of real numbers. So I am actually going to factor out the quantity 4 from both of these terms. Okay. So I've got to do that. So I'm going to say parentheses for parentheses x squared minus 4x, because I have to think what factor can I multiply this number by to get this number back. And so it has to be 4 times 4. And that's how I figure that out. And so then I'm going to go ahead and put 2 parentheses in. Just helping me stay keeping in track of my order of operations. And I was really surprised how easy it was to graph the ellipse. It's been several years since I've even thought about them, and you know, I remember learning about them in college algebra many years ago, and they were I just remember them being overly complicated and different. But this method was pretty straightforward. The hardest part was the algebra. So maybe in my elementary mind set, the algebra was what got me. But now it's easy. So I have plenty of practice. But we're going to go ahead and do the same thing that we did here, just getting it neat and organized. And we're going to do that with this one as well. So parentheses, and I think, yeah. So 9 times 6 is 54. So this is where your multiplication tables come in handy sometimes. This upper level math, just being able to recall all those values. So this is going to be 9 times y squared plus 6y, and then leaving some room and putting both your parentheses in there. And the reason why we did that was because here in a minute, when we perform this method, the next step of the method, we still have to, because we have this equal sign we're dealing with, we have to keep things equal. So it's almost like you have to, when you're balancing the scale, no matter how much you take from one side or the other, if you're going to keep it balanced, you have to add it to the other side of the scale. So it's kind of what you're doing. When you're saying something is equal, you have to always keep it equal by making sure that you're performing the very same operations that you do on both sides. Both sides are getting equal treatment. And that's kind of how you keep it equal. And it's a kind of a big deal because when I've already factored out a 4, so when this magic number that I come up with to make my square perfect, when I add it here, I have to make sure that I also add it here so that I'm performing, legal operations in math and making sound calculations. All right. Because anyone can say anything and anybody can make anything mean anything they want, but we're looking at specific definitions and specific operations and methods in math, and that's fundamentally why I really appreciate the subject. All right, so with that being said, we'll go ahead and we'll do our completing the square method. We're taking this, I don't know what I was doing, gibberish. So we're taking our middle linear term here, and we're going to take that number of sign and everything, and we're going to divide it by 2. And -4 divided by 2 is -2. And we're going to take this number. Now, why did I put 2 negatives? I'm getting ahead of myself. We're going to take that number and we're going to square it. So we'll get, when you square a negative, of course, you're going to get a positive. So we're going to take that number and we're going to add it here. And then we're going to take and we're going to say 4 times 4 is 16. And that is the actual number that we have to add to this side is 16. So we're going to say plus 16 here. And then what you've done, I'm going to get my eraser so I'm not getting my hands all dirty. I'll look like a mechanic. And people say, to you, are you a car mechanic? No. Not quite. All right, so we've got 4 times, and I'm going to go ahead and erase this right here. But I'm going to remember this -2 because that's what I'm going to write in here. Okay, that -2. We're going to say x minus 2 quantity squared. And we're just going to remember that that parentheses was there, and we can remove the outer parentheses. We don't need it anymore. And then we're going to do the same thing here with this 9. So it's going to be plus 9. We'll go ahead and write it because we're going to remove that second parentheses in a minute. So we're going to take this middle term 6, and we're going to divide it by 2, which is 3. And we're going to square that number, which is 9. And I'm going to add it here. And then I'm going to say 9 times 9, because remember, you have to multiply. You're not adding actually 9, you're actually adding 81. But we pulled that factor out, if that makes sense. So let's see. All right. So 9 times 9 is 81, and that's the number. So we're going to add it. We added 81 here. We're going to add 81 here. Just making sure that we are adding the same numbers to both sides. And same thing here. We're not adding 4 to both sides. We're actually adding 16. If that makes any sense. More importantly, we've made our perfect square for our y terms, and that's going to be 9 times, and then you're going to say y plus, and that's that number that you have before you squared it, 3 quantity squared, and that equals, and then we have to figure out what 81 plus 16 minus 61 is. And so that's 97 minus 61. $97 minus 61. Let's see, what is that? What's 69? Hold on, it's 90. It's negative 61, positive 97. For some reason, my brain's being stubborn. Anyway, it's 36. Seeing is believing. So I gotta double check it. So trust my mental math anyway. Plus, it's good standard procedure to have a double checker. And honestly, in a perfect world, in my perfect world anyway, I would have several people all doing math together, all checking each other's work, all contributing to the solution. That would be amazing. But all right, we'll take what we can get for now, though. So we've made our perfect square, and that equals 36. We'll move it over a little bit, 36. And then, yeah, so we've solved it, but we haven't exactly put it in standard form yet. So I'll go ahead and do that. I feel like I'm a little distracted today, so I'm just trying to calm down, slow down, and not be so excited. I feel a little bit excited mood today for some reason. Okay. All right, almost there. And let's see. Last step is, see, we're putting in this form, so this number has got to be 1. So what we're going to do is we are going to divide both sides by the only number that can make this number 1. So anything divided by itself is equal to 1. So, and again, we're performing, because of this equality and because of the properties of real numbers, I'm allowed to perform any operation for real numbers as long as I do exact operations to both sides. And that's the way you keep it legal. So we've got this thing. We've got 4 times x minus 2 y squared over 36 plus 9 times y plus 3 quantity squared over 36, and that is going to equal 1. And then one more step is just putting things in its simplest form and reducing down. And so I know that 4 times 9 is 36. So this is going to cancel, and it's going to reduce down. So it's going to give me x minus 2 quantity squared over 9. And then there's a plus, and this plus is what distinguishes the hyperbola at this point from an ellipse. This would be a minus if it was our hyperbola. And then 9 goes into 36, that's 4 times. So that's going to be plus. These will reduce down, and you'll have y plus 3 quantity squared over 4. And then that's going to equal 1. And then you're going to look at it, you're going to say, which one's bigger, 9 or 4? Okay. And 9's bigger, so 9 has to be A. because A has to be greater than B, and B has to be greater than 0. This is something A, B, 0. And so we're going to say A equal, or A squared rather, because you have A or B squared. So this is A squared equal 9, and B squared equal 4. So then when you you have something squared, you just perform inverse operations. You're going to get A equals plus or minus 3. However, when you're dealing with distances, and A is a distance, you can't have negative distances. You can only have negative direction. So A is a distance of 3. So same thing with B, taking the square root of both sides, you're getting B equals plus or minus 2. And then, so we've got our B values, we can, and our A value. What we're going to do now is we're going to look at our form again. And this is the beauty of the reason why we put it in this form, is so that we can find A, which is the distance from what I learned, that A is going to be so it's your horizontal chord. So on this one, this is obviously the one we did yesterday, but A would be associated with the x-axis, and it's half the distance from the center out. So we're talking about that distance there. And then this is B. This is A, and that is B. So that's what we're finding when we're putting in this form. We're also locating H, K as well. So looking here at H, K, my center, and that's basically what you need. You need to know the length of these chords and the center where it's located. And then after that, it's really easy to sketch that. So we're almost there. The center, it looks like it's at positive 2, comma, negative 3. And again, we're just pulling those values from the form. This is the form. If the form is negative and your value is negative, then your resulting value is positive. But in the form, if your equation is positive, the form is negative. So you have to remember that two negatives multiplied together make a positive number. So the only way that you could get a positive result in your equation is that if your value was negative. So hopefully that makes sense. So yeah, I think I just realized that my center is almost going to overlap my other ellipse. So I'm going to go ahead and erase this one. And tragically, I wanted to kind of have them on the same one, I was thinking, but I didn't. If I would have graphed it before, then I would have been able to make sure and find one, but yeah, it's okay. It's all right. No big deal. I mean, in my opinion. We'll just sketch a new graph. And that was not straight, but that's okay. And we're going to look at this new ellipse. And I've been saying it right, and then all of a sudden today I started saying it wrong. So, all right. So we have our center here at positive 2, 1, 2. And negative 3. So we'll say 1, 2, 3. Positive 2, negative 3. Right here is my center. No, I don't need to write that out. Not necessary. And then since I have my A is associated with X, A is 3, then it's going to lead to, so my major axis is 2A. Okay, and the minor axis is 2B. So after you locate your center, you're remembering the A is the horizontal chord from the center out. So if I'm at 2 and I go to this direction, I'm at the y-axis here. And then if I'm at 2 and I go out to this direction, then I'm going to be at positive 4. So 2A is 2 times 2, which is 4. So we should have 4 units. 1, 2, 3, 4. And that, again, that's just my horizontal, the horizontal chord. The minor chord is associated with Y, and the B value is going to be a vertical value. And so it's 2B. Wait, A is 3. Oh my goodness, I'm going to graph this wrong. I'm glad I caught that mistake. All right. Just kidding. 2A. A is not 2. A is 3. Silly me. But if I had people like a classroom, then my students would laugh at me. But they would also catch it and they would be like, hey, Professor L, you know, you're making a mistake. What about this? How did you get that? And then it's a valuable learning experience. So, but I'm up here hanging out, literally by myself. So it's okay. I'm glad I caught it. So we've got 3 right here. Okay, good. So 2, -3. Let's regraph our center. And then if we go out here, it's not going to be on the y-axis. It's going to be at -1 here. So here's our 3, and then it's going to put me at 5, it looks like. Here, 1, 2, 3. All right, so we're doing a little bit better now. And then let's see, what else we got to do. 2, 3. 1, 2, 3. I guess it just looks a little bit, because of this line, I think it's just interfering. I think we're good. And then 2B is going to be 2 times 2, which is 4. So we've got 1, 2 up is going to put me at -1. And 2 down, 4 is going to put me at -5. So the minor axis and the major axis. So this is going to be, okay, this distance right here is A, and this distance right here is B. And here is your ellipsis. Okay. The domain and range. We're going to have a bracket because this function is only existing from -3 to +5. You'll say bracket -3 comma 5. and then the range is also going to be a bracket. And it's the lowest value, which is -5 to -1. But more importantly, we were able to successfully change forms of the equations. We went from general form to standard form so that we could use the form to pull out our values so that we could get a very, very rough sketch of an ellipse. So where is the ellipse existing? What quadrant? How big is it? Just basic general knowledge about the ellipse. There are other values for calculating conic sections. There's the eccentricity, which is, it's kind of, it's a kind of a complicated topic, but there are a lot of resources out there all over the internet, and people talking and showing graphics, and they have this fancy software and stuff. So I guess this is just for this is a different kind of thing. What we're doing, we're just articulating a method from hand from scratch, trying to the goal is to be able to graph these really hard complex equations without the use of tools at all, like no calculator, no, obviously I'm using a lot of technology right now, but what is the capability? What is the understanding? What can I create? And what can I articulate from scratch, from nothing? So that's kind of where we're at with this. And I am going to go ahead and call it early because I've basically mission accomplished. I did successfully graph this thing, and I don't have any questions or anyone in the chat, so I am going to call it good. And just say, if you are watching my videos and you are then I really appreciate that, and I know that it's a lot. Time is so precious, but yeah, if you do need help with your math, or you know anyone that needs help with math, and this is a perfect platform, to be. It's a very good tool, and it could be, very helpful and beneficial to a lot of people, and taking education back and everything. So again, I'm gonna go ahead and say goodbye for now. And I will be back tomorrow, trying to find something really good and relevant. And in the meantime, yeah, so thank you so much for tuning in and watching my videos, and letting me know that you like the videos. That would be good also. But yeah, anyway, thank you so much for watching, and I will see everyone again tomorrow. Bye.